Hello, hi everyone. Welcome to the Student the Brand. So in the previous video, human in colorful world until rainbow formation by water droplet. We discussed until here refraction. So what is the phenomena involved in the formation of rainbow by water droplet? What is the phenomena involved in the formation of rainbow by water droplet? Okay. So refraction, dispersion, internal reflection, refraction, dispersion, and internal reflection, refraction, dispersion, and internal reflection. Okay. Now, okay, human and colorful word. So now you can see here. Stars twinkle. So stars twinkle, planets do not twinkle. So what is the reason behind of this? Stars twinkle, while planets do not twinkle. So because of atmospheric refraction, stars twinkle. So normally, if you're taking light rays are coming from the star, so from far distance. So because of the atmosphere, keep on refraction takes place. Okay. So in the atmosphere, so everywhere. So what are the particles are present? It won't be constant. So one it will be hotter air, one it will be colder air. One place it will act as a rarer medium, another place it will act as a denser medium. So because keep on it changes direction. If the light ray is coming from stars, it keep on changes direction. So because of that reason, so stars appear twinkling, whereas planets do not twinkle because so planets are point size sources. So one place it will be dark, one place it will be bright, one place it will be dark, one place it will be bright. So overall combination, overall effect will be nullified. Overall effect will be nullified. That is the reason. That is the reason. Planets do not twinkle, whereas stars twinkle. And advanced sunrise and delayed sunset. Advanced sunrise and delayed sunset. So due to atmospheric refraction, I will draw diagram and explain. So listen carefully. I am taking this Earth. I am considering Earth atmosphere. This Earth atmosphere. Earth atmosphere. So this is the origin I am taking. So here is the sun. Sun. Okay. So sun will be the below the origin. Sun will be below the origin. Okay. So like this. So when the light rays are coming from the sun, So because of the atmosphere refraction takes place. Because of the atmosphere refraction takes place here. So light rays are coming like this. So because of the atmosphere, when you are standing here, okay, so because of the atmosphere, the sun appears here. The sun appears here. The sun. So because of the atmospheric refraction, Actually, sun is here only. Whenever the light rays are coming from the sun, because of the refraction atmosphere, this is the atmosphere, Earth atmosphere. Okay, so atmosphere of the Earth. This entire portion is dotted lines. Whatever I am representing, the dotted lines is atmosphere. So this entire atmosphere. So because of the atmosphere, so refraction of light. Okay, so bending of the light at this portion. Then if you are drawing the dotted lines, that is apparent position. Actually, real position is here. That is apparent position. Apparent position. This is actual position. So because of the atmosphere, refraction takes place. The sun appears here. So due to atmospheric refraction, the sun appears 2 minutes advance sunrise. 2 minutes advance sunrise. So this I am taking the origin. Okay. So 2 minutes advance sunrise and even evening also delay sunset because of the earth atmosphere. Because of the earth atmosphere. I hope it is very clear. And delay sunset and advance sunrise. So delayed sunset and advance sunrise. So because of the atmospheric refraction. Okay. And so we are discussing one more point, that is sun appears reddish color during evening time and morning time, and in the noon time it appears white and remaining time it appears blue color. So due to scattering of light, I'll explain scattering of light in detail. So I'll explain the scattering of light in detail. So listen carefully. Scattering of light, I'll explain in detail. Okay. So we know the wavelength. So I'm taking here light ray is coming. So this is the crust and this one is the trough. So this distance is called wavelength. And this one also wavelength. So the distance between two consecutive crusts or two consecutive troughs is called wavelength. The distance between two consecutive crusts or two consecutive troughs is called wavelength. Okay. So if you are taking the particle here, I am considering this a particle. So whatever the particle incidenting on it, okay. So here, if the light ray is coming and incidenting on the particle like this, so if you take this wavelength, the distance between two consecutive crust or two consecutive trough is called wavelength. The distance between two consecutive crusts or two consecutive trough is called wavelength. What are the light ray incidenting on that particle? The particle size is comparable to the wavelength of the light. Then the particle will absorb the light and re-emit in all directions. With a different intensity. Okay. So that particle will absorb the light. Okay, the size of the particle is comparable to the wavelength of the light incident on it. Then the particle will absorb the light and re-emit in all directions with a different intensity. Is called scattering of light. Scattering of light. Okay, scattering of light. I hope it is very clear to you all. So the re-emission of light in all directions with a different intensity. Is called scattering of light. So coming to the Tyndall effect, the path of the light becomes visible when it is passing through the colloidal solution. So if you send the white light through colloidal solution, because of the colloidal solution, scattering of light takes place. The path of the light becomes visible when it is passing through colloidal solution. So when you are moving on the road, so in middle of the road, in between the trees, so a number of trees will be there on the road. So in between, the middle of the trees, small narrow of light beam will fall. So in that you can observe the dust particle. Best example, when in the morning time, if you open the windows, so there is a beam of light. Okay, so a beam of light will fall. So you can observe the dust particles are flying in that beam. Okay, that is about a Tyndall effect. Okay, and these are the examples for Tyndall effect. And if during rainy time also near to the bulb, okay, so bulb, so street bulb, if you say near to the street bulb, so during that rain time, so that the particles, okay, the small, the water particles, moisture particles will fly in that, so it will fly near to the bulb, you can observe. Okay, so that is also Tyndall effect, right? I hope it is very clear to you all. This is about scattering of light, Tyndall effect, and atmospheric refraction. This is about colorful phenomena. I hope it is very clear to you all. That is about a human and colorful world. Now we will discuss about electric current. After that, magnetic effects of electric current. So actually, we thought to do in a single video because time is too long. So nearly almost first video 1 hour, second video 1 hour, third video 1 hour. This is the fourth video. This also it will take 1 more hour. So like that. So that is the reason I'm trying to split. So I'm splitting the video into 4 parts. Still one more part also there. So maybe this will take 1 hour and that also 5 parts. Overall 5 parts. Okay, that's the reason. So if you like the video, please do like, share, and subscribe to Student Brand. So I already given the Instagram link. You can like, share, and follow. Electric current finally third chapter. So third chapter, electric current. The rate of flow of charge is called electric current. The rate of flow of charge is called electric current. Electric current. Electric current. Electric current. The rate of flow of charge. The rate of flow of charge. I equal to Q by T. I equal to Q by T. SI unit of electric current is ampere. SI unit of charge. SI unit of current is ampere. SI unit of charge. Coulomb. SI unit of current. 1 ampere equal to 1 coulomb per 1 second. 1 ampere is defined as 1 ampere is defined as 1 coulomb per 1 second. So SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second. So SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second. So 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. Right? Yes. So inside of the conductor, there are many charges will move. So it is not only 1, 2, 3, 4, 5, 6. Only one electron if it is moves, we can't say current is flowing. Only two electrons if it is flow. So only two electrons, only three electrons, only three protons, only three electrons if it is goes, we can't say current is flowing. There are many charges are moving inside of the conductor. That's why, that is the reason. So quantization of charge Q equal to plus or minus Ne, quantization of charge. And that is N is the number of charge. Number of charges are moving inside of the conductor. N is the number of charges moving inside of the conductor. So Q equal to plus or minus Ne, I equal to Ne by T, I equal to Ne by T, I equal to Ne by T, I equal to Ne by T. Yes or no? Yes, I equal to Ne by T. Now we can go through that. Next one. Current I equal to Ne by T. N is the number of charges. C is on one electron, 1.6 into 10 power minus 19 coulomb. On one electron, how much charge is present? On one electron, how much charge is present? On one electron, 1.6 into 10 power minus 19 coulomb. So in 1 coulomb, so here in 1 coulomb, 1 by 1.6 into 10 power minus 19, that is nothing but 1 by 1.6 into 10 power 19. So then you'll get 1 by 1.6 into 10 by 10 into 10 power 19. So that is nothing but 10 by 16 into 10 power 19. Then you'll get a 0.625 into 10 power 19. Then 1 coulomb will get 6.25 into 10 power 18 electrons. So on 1 coulomb 6.25 into 10 power 18 electrons are present. So very very important. So electric current. So remember all these points, whatever we discussed, right? So 1 ampere equal to 1 coulomb per 1 second. So SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second. 1 ampere is defined as 1 coulomb per 1 second. So quantization of charge Q equal to plus or minus Ne, and 1 electron 1.6 into 10 power minus 19 coulomb. So I equal to Ne by T. So this is about this the data, right? Next, electrical appliances. We'll discuss about electrical appliances. So electric current I equal to Q by T we discuss now. Electrical appliances. First one is cell, positive terminal, negative terminal. Second one is battery. Battery. And third one is open switch. And the fourth one is closed switch. So this is the open switch and closed switch. And coming to the fifth one, resistor, 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 resistor. Resistor, 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 resistor. Okay, resistor is a device which is used to oppose electric current in the circuit. Resistor is a device which is used to oppose electric current in the circuit. Coming to the sixth one. Rheostat. Rheostat is a device which is used to regulate the current without changing the voltage source. So cell, battery, open switch, close switch, resistor, rheostat. Coming to the ammeter, ammeter. So wire joining, next one wire crossing, 11th one, bulb. So cell, battery, switch, open switch, close switch, resistor, rheostat, ammeter, voltmeter, wire joining, wire crossing, bulb. Okay, so these are the electrical appliances. Okay. So cell, battery, open switch, close switch, resistor, rheostat, ammeter, voltmeter, wire joining, wire crossing, and bulb. Here, resistor is a device which is used to oppose the electric current in the circuit. Resistance is the phenomena of opposing the electric current. And SI unit of resistance is ohm. SI unit of resistance is ohm. Okay, SI unit of resistance is ohm. And coming to the rheostat, without changing the voltage source, it can alter the current. That is called rheostat. Next one, ammeter. Ammeter is a device which is used to measure the electric current. Ammeter is connected in series combination. Coming to the voltmeter. Voltmeter is a device which is used to measure the potential difference which is connected parallel combination in the circuit. Okay. SI unit of current is ampere. SI unit of potential difference is volt. So next one we'll discuss about electrical circuit. Electrical circuit we'll discuss. Electric circuit. So electric circuit is nothing but a continuous and closed path of an electric current. A continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric current is known as an electric circuit. I am taking the cell here. So, ammeter. So, bulb I am considering here, bulb. La 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 la. Conventional current. Conventional current. And the second one is electric current. Electric current. Electric current. Conventional current and electric current. So, my dear students, listen carefully here. Electric circuit is nothing but a continuous and closed path of an electric current. A continuous and closed path of an electric current is known as an electric circuit. Coming to conventional current. Conventional current is nothing but the flow of positive charges. Positive charges are moving from positive terminal to negative terminal. Positive charges. Whereas electrons, positive charges will move from positive terminal to negative terminal, whereas electrons will move from negative terminal to positive terminal. Conventional current is nothing but the flow of positive charges is considered as conventional current. The flow of electrons is known as electric current. So conventional current, so positive charges will move from high potential to low potential, and whereas electrons will move from low potential to high potential. So very important, listen carefully. Electric circuit, a continuous and closed path of an electric current is known as an electric circuit. So this total you can see. So conventional current. What is a conventional current? The flow of positive charges. Positive charges will move from positive terminal to negative terminal. Electric current will move from negative terminal to positive terminal. That is charge is electrons. Electrons will move from negative terminal to positive terminal. Positive charges will move from positive terminal to negative terminal. Conventional current and electric current. Conventional current and electric current. Okay. So very important. Positive charges will move from high potential to low potential, whereas electrons will move from low potential to high potential. So there is one question related to this one. Will electrons will move from potential to low potential or low potential to high potential? So that is a question. And define electric circuit, SI unit of current, and define the SI unit of current. So 1 ampere equal to 1 coulomb of charge flowing through unit cross section area per second. Okay, so from one point to another point we have taken like this, we can say. So this electric current, electric circuit, conventional current and electric current, and electrical appliances also we discussed. Electrical appliances, bulb, cell, battery, open switch, closed switch, resistor, rheostat, ammeter, voltmeter, and wire joining, wire crossing, bulb. Okay. Now Now we'll discuss about potential difference and electrical potential. Potential difference and electrical potential. Potential difference. Potential difference. Potential difference is nothing but this is a positive charge. So from point A to point B, positive charge from point A to we are doing some work. We are doing some work to bring unit positive charge. We are doing some work to bring unit positive charge from one point to another point within the conductor. So we are doing some work to bring unit positive charge from one point to another point within the conductor is called potential difference. 1 volt is equal to 1 joule by 1 coulomb. So 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point within the conductor. Within the conductor. That is called potential difference. SI unit of potential difference is volt, SI unit of work is joule, SI unit of charge is coulomb. Okay, next. So we'll discuss about one more point, electrical potential. Electrical potential. Electrical potential. So we are doing some work to bring unit positive charge. So we are taking this a positive charge, we are doing work. So this I am taking the infinity. Suppose I am considering this a required field. We are doing some work to bring unit positive charge from infinity to the required field. From infinity to the required field is called electrical potential. Potential difference is nothing but work done to bring unit positive charge from one point to another point within the conductor is called potential difference. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point within the conductor is called potential difference. Work done to bring unit positive charge from infinity to the required field is called electrical potential. Is called electrical potential. I hope it is very clear to you all, right? Yes. Next. So coming to the Ohm's law, Ohm's law, Ohm's law, Ohm's law. 1, 2, 3, 4. So this is a resistor X and Y. So current is passing like this. So potential difference, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it at constant temperature. The potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it at a constant temperature. V is directly proportional to V equal to IR. V equal to IR. Now materials required. Materials required. Materials required. First one. So you have to take 4 cells. 4 cells of 1.5 volts each. And the second one, nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Nichrome wire is 0.5 meter length. And coming to the third one, 4 cells 1.5 volts each. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals. And coming to the ammeter, coming to the fourth one, voltmeter, and coming to fifth one, switch. Switch. And coming to sixth one is connecting wires. Connecting wires. Okay. Sixth one is connecting wires. Once again, check the materials. What are the required materials? 4 cells of 1.5 volts each. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Ammeter, voltmeter, switch and connecting wires. Okay. Now, procedure. What is the procedure? Procedure is, first you have to connect one cell. First connect one cell and note down the reading of ammeter and voltmeter. Connect one cell and note down the reading of ammeter and voltmeter. Connect two cells. Connect two cells and note down the reading of ammeter and voltmeter. Repeat the process for 3 and 4. Repeat the process for 3 and 4. So you have to repeat the process for 3 and 4 cells and mention the values, and so write in the tabular form. Number of cells. Ammeter reading, voltmeter reading, V by I form, that is R. 1, 2, 3, 4. 1, 2, 3, 4. Okay. 4 cells we are considering. 4 cells you are taking. So what are the values you measure? Those values you can mention in the tabular form. Draw the graph for Vi. So if you draw the graph for Vi, V on y-axis, X on x-axis. So the graph is linear for ohmic conductors. The graph is linear for ohmic conductors. The graph is curved for non-ohmic conductors. So V on y-axis, I on x-axis. Ohmic conductors mean the substances which obey Ohm's law, those are called ohmic conductors. The substances which obey Ohm's law, those are called ohmic conductor. The substances which does not obey Ohm's law, those are called non-ohmic conductors. Okay, Ohm's law gives the definition of resistance. Ohm's law gives the definition of resistance. So that's enough for today class, the until Ohm's law. So thank you so much for joining and attending. So you can just to go through the Instagram link I already kept in that description. You can check in the description. So thank you so much for joining and attending, listening and supporting. So do support, and if you like the channel, if you like my explanation, if you are new to the channel, so do like, share and subscribe to Student Brand. So we'll discuss more about remaining points. So we'll discuss in the next class, next video. Okay. So thank you so much for joining. We'll see you in the next class. Right.